All right, so these three are on your reference sheet, so you do not have to worry about memorizing them at all. You can just use the sheet to do it. And they're used whenever you want to find the sine, cosine, or tangent of two angles added to each other. So I'm going to show you guys something down here. You don't have to write this down. But if you had the sine of 30 degrees plus 45 degrees, a lot of people think that you can do the distributive property with sine and cosine and tangent and do this and have it be true. So let's see if that really is true. We'll use a calculator. Okay. So if we start off and we did the sine of 30, my calculator is in degrees. 30 plus 45 degrees. You get that decimal. So those two things are definitely not equal. So you cannot do like that kind of distributing with trig ratios. So don't try it. You can't do it. So we have to have another way. We have to have another way to find the sine of 75 degrees because that's not one you can do a hand trick for. So what we can do is one of these sum and difference formulas. So this first example isn't 75 degrees, but it's kind of the same thing. We want to find the sine of 7 pi over 12. If 12 is your denominator, it is not a special angle. We can't do a finger trick to figure it out. But we do know, or telling you that if you add pi over 3, which is special, and pi over 4, which is special, it gives you 7 pi over 12 because you find a common denominator and all that. So what you can do is rewrite the sine of 7 pi over 12 as the sine of pi over 3 plus pi over 4. All right, and then anytime that I want to find the sine of two angles added to each other, I can use this formula up here. So in the place of s, I'm going to put in pi over 3. And in the place of t, I'm going to put in pi over 4. All right, so we'll do that. All right, so all I did was just replace s with pi over 3 and replace t with pi over 4. Okay, and then all of these I can find using the hand trick. So each one of those is just going to be some kind of fraction. So whenever I want to find the sine of pi over 3, I use the pi over 3 finger, and it's going to be the square root of the bottom fingers over 2. And the cosine of pi over 4, I'm going to use the pi over 4 finger, and it's the square root of the top fingers over 2. All right, you guys figure out those two for me, please. All right. And then that's all the trigonometry of this problem. The rest of it is just algebra and rules for multiplying and adding fractions. So when we're multiplying, remember you multiply across the numerators and across the denominators. And there's really not a lot you can do, but we can make this one fraction. So one fraction where the common denominator is the denominator and then you just add those numerators on the top. And we can't add a square root of 6 and a square root of 2. So this is it. This is all we can do. So that is what the sine of 7 pi over 12 is. Bless you. And without a calculator, that's the only way we can figure it out. There are some other identities that maybe would work, but this is probably the best one. All right. So that's pretty much it for sine. And cosine is very similar. On B, though, I threw in a subtraction. And we do not have a formula for subtraction, but we can make this work for addition. So 13 pi over 12 is not special. So only the special angles have a denominator of 6, 4, and 3. So if it's reduced, the denominator is 12, it's not special. But I can subtract 2 special angles and get that. So what I would do, since I don't have a formula for subtraction, I'm going to rewrite this as the cosine of 5 pi over 4 plus negative pi over 6. I didn't talk about this in the first example, but what quadrant is 5 pi over 4 in? The third quadrant. And so whenever I use this formula up here, and I'm doing the cosine or the sine of 5 pi over 4, are they going to be positive or negative? The cosine and sine in quadrant 3? Both are negative, so keep that in mind. All right, so what I'm going to do, just like the last one, I'm going to use this cosine of s plus t formula, and I'm going to put 5 pi over 4 in for s and negative pi over 6 in for t. All right, and then we can do the hand trick, and we are also going to have to think a little bit about even and odd functions too. But we already said the cosine of 5 pi over 4 is negative, so I'll go ahead and put that as a negative. And then we'll use the pi over 4 finger as the square root of the top fingers over 2. All right. Is cosine even or odd? Even. Whoa. All right, so what happens to the negative on even functions? It disappears. So you just drop the negative. So the cosine of negative pi over 6 is the same as just the cosine of pi over 6. So you would use your pi over 6 finger and do the square root of the top over 2. Right, and then we already said the sine of 5 pi over 4 is going to be negative because it's in quadrant 3. And then it's going to be the square root of the bottom over 2. All right, is sine even or odd? Odd. And so for odd functions, the negative, you can't just drop it. So the answer would be the opposite of what it would have been if it was positive. So you keep the negative. So the sine of negative pi over 6 is the same as the negative sine of positive pi over 6. And so we use the pi over 6 finger. It's the square root of 1 over 2. All right, so that is a possibility since they're not putting the subtraction rules on the formula sheet. They may expect you to do it that way, or they may just not put any subtraction. I don't know. I don't trust them 100%. So we're just going to be prepared. All right, so now we're going to multiply across the numerator and across the denominator. And then what do you get when you multiply a negative times a negative times a negative? another negative. All right, so it's going to be one fraction with the 4 in the denominator, and then just bring down your numerators. So that looks very similar to the one we just got. And they will. Like, there's only so many possibilities for what you're going to get on special angles. So you'll see this square root of 6 and square root of 2 on the top. Sometimes it's positive, sometimes it's negative. You just have to work it out. Okay. Now the tangent formula is definitely the most difficult one to use because you just have fractions, and then like the tangent is probably going to be some kind of fraction. So you have fraction inside of fraction. So it's just a little tedious. So let's look at a tangent question. So 5 pi over 12 is not special, but these two add to give it, and they're both special angles. So we can rewrite this as the tangent of pi over 4 plus pi over 6. We'll use the tangent formula for sums and put pi over 4 in for s and pi over 6 in for t. Okay. Now pi over 4 and pi over 6 are both in quadrant 1, which is great. We don't have to worry about negatives. And so we'll use the pi over 4 finger and do the square root of the bottom over the square root of the top. And what are we going to get? Just 1. Right? And then for a tangent and pi over 6, the square root of the bottom over the square root of the top would give you 1 over the square root of 3. What does that reduce to? Good job. Square root of 3 over 3. All right. And then down here on the bottom, we already found both of those things. So we're just going to multiply them together. All right. So that's the trigonometry part of this problem. Hey. Okay. Okay. And so the rest of it is algebra stuff that is kind of weird. So there's two problems with this. One problem is we have these little fractions inside of a fraction. The other problem is we have this radical in the denominator. So let's talk about the fraction inside of a fraction first. So what can I multiply this whole numerator by and this whole denominator by so you won't have fractions, little fractions anymore? Well, if you did that, when you multiplied it by this, you would still have a fraction. Just multiply it by 3. All right, so you're going to multiply to remove the little little fractions. And what she said was what everybody has said today. Then they immediately just want to multiply by the reciprocal. And if this was the only thing you had to multiply it by, then that would be perfect. But because you have to distribute it, you don't want to multiply by another fraction. All right, so we're going to distribute those 3's. So that's better. Still not perfect, but it's better. And there was a question on an old challenge exam that they left the answer like this. Now, it was a way more difficult question to do, and that they left the answer with a radical denominator. So just check your answer choices. It's possible they might leave it like this. More than likely, though, they won't. And so we have to multiply this by something so you don't have a radical in the denominator anymore. Do you guys remember what it's called? It's been a long time since we've done this. It starts with a C. It's okay. It's the conjugate. multiply by the conjugate of the denominator.
The last one, because you multiply that 3 by all 3 of the numbers in the denominator, right?
Well, kinda. Like this is like one thing. That
Okay.
okay. So what do you guys remember what the conjugate is? It's okay. So it's going to have the same terms, just a different sign in between. All right, so this is a little tedious. So in the numerator, we're going to have to do all the multiplying. So distribute 3 and then distribute the square root of 3. All right, and then the denominator, we're going to do a shortcut multiplication. Since they're conjugates, you can just do 3 times 3, a negative square root of 3 times the square root of 3. Right. And then just like the sine and cosine of a sum, the tangent of a sum, they all kind of work out very similarly. So we would add the like terms here. And then these all will reduce. So they all reduce by 6. So 2 plus the square root of 3. So for the tangent of a sum, you're going to have like 2 plus the square root of 3, 2 minus the square root of 3, negative 2 plus the square root of 3. You'll see those same answers over and over and over again. But that is what the tangent of 5 pi over 12 is. All right, so we've seen one of each. Tangent, definitely most tedious to get to the right answer. But it's really just plugging into the formula, doing the hand trick, and simplifying. All right, so sometimes you'll see a question that's written in a way that it looks like you're going to use the formula, but you're actually not going to use the formula. For the formula to work, these angles you put in have to be special angles. If they're not special, then you can't use the formula. Like it's not going to work. So if these are both special, now special in radians means the denominator is 3, 4, or 6. Technically, the denominator could be a 2, but probably won't be. So if they're both special, use the formula. A denominator of 12 is not special. So if you try to use the formula with these, when you go to find the sine of 5 pi over 12, you don't have a finger for that. So if they're not special, then you're going to go ahead and subtract or add, depending on the problem. And then use the hand trick. And they'll be so much faster. So sometimes they're written in a way to trick you. Don't let it trick you. Or if it does trick you, just remember, oh yeah, they tricked me. I'm going to go back and now I'm going to do it the right way. All right. So on this one, are these special? No. So we're going to go ahead and add them together. So it would be the tangent of 12 pi over 16, which reduces to 3 pi over 4. Is that special? Yes. What quadrant is 3 pi over 4 in? 2. So is tangent going to be positive or negative in quadrant 2? Negative. And then we just use our pi over 4 finger. What is the tangent? Square root of 2 or square root of 2? 1. So fast, so much faster. So try to pay attention. If you're about to use the formula, that these angles that you're plugging into the formula have to be special. If they're not special, it's not going to work. We still have a few more examples. They are super fast, though. They're not anywhere close to as long as the ones we did on the front. So on the back, these, it's like the formulas have already been applied and we're moving backwards. And so for A, we have the sine of 3 cosine of 1.2 plus cosine of 3 sine of 1.2. So if you're looking at your identities, which one does that look like? Where it's sine cosine plus cosine sine. Looks like the sine of a sum. So what are the two things you're adding? Very good. That's your S and that's your T. So that is the same thing as just the sine of 4.2. 4.2 radians. We don't know what that is, so we just stop. There's no way we can figure that out without a calculator. All right, what does B look like? A tangent. And then what are the two angles you're adding? Yes. All right, and then that's going to be the tangent of 75 degrees. Without a calculator, we don't know what that is. 75 degrees is not special. For degrees, for the angles to be special, they're multiples of 30, 45, or 60. 75 is not. So that's it. Okay, so this last one, we're going to do the same thing, but we're going to take it one step further. So what does that look like? I was about to write it without you telling me. It looks like the cosine. And then the two angles are going to be basically what you see, the two angles, pi over 16 plus 3 pi over 16. All right, so you add those, you get 4 pi over 16, which is pi over 4. Pi over 4 is special. Pi over 4 is actually super special. So if it's an actual finger, I say that it's super special. So what is the cosine of pi over 4? Very good. All right, so what questions do you guys have? All right, still need to know the hand trick. It's very, very important to get through this. So your assignment is at the bottom of this. The last 6 are going to not be super long. They're just like the ones we just did. And then out of these 6, one of those, you're not going to use the formula. Don't let it trick you. So anyway, you can do that on another sheet of paper.